class. So what we did today is we went over lesson 1. So we talked about graphing points on our number line, comparing and ordering integers, recognizing sets of numbers, and to find the absolute value of a number. So basically what we see is just reviewing integers, whole numbers, they can be positive or negative, and that includes 0. So here, this is what we call a set. So on either end, we have what are called braces. And then this dot, 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 that's what we call an ellipse. That means it continues forever in that direction. So here, this means going further this way. If we extended this set, it would go all the way towards negative infinity. And here, the ellipse, the dot, 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 would extend all the way towards positive infinity. So every number within the set, we call that an element. So yeah, integers, whole numbers, positive or negative, they include 0. All right, so looking here, counting numbers, just like 1, 2, 3, really important to note the difference between counting numbers and whole numbers. So whole numbers, there's an O in the whole, and that just reminds me that there's a 0 when we think about whole numbers. So whole numbers include 0, 1, 2, 3. Counting numbers, just 1, 2, 3. So just important to note the difference there. And then, yeah, one thing I do want to write is, let's see, oops, wrong pen. Yeah, so when we think about the set here, so I'm just going to draw my brace, and then it's important, counting numbers start at 1, so we don't want any dot, dot, dot. We'll just do 1, 2, and then, that's a 2, sorry, and then 3. And then here, since counting numbers go on forever, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to go and put the dot, dot, dot. And then just as we have one brace over here, we need to finish it, throwing our other brace on right over here. And then I'm just going to fix our brace, or pardon me, fix our 2 right there. Okay. And then here, it's going to be the same set as above, except for we need to make sure we remember include 0. So I'm just going to go ahead and draw that in. So we got 0. Again, it's starting at 0. It's not before, so we don't want any dot, 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 any ellipse before then. 0, 1, 2, 3, so on and so forth. I'm just going to stop there. But we see now we have our set of whole numbers. And it's okay, I didn't include the 3 because the dot, dot, dot is implied that the 3, 4, 5, 6, 7, 8, 9, 10, all the way towards positive infinity is included and continued there. All right, so comparing integers, what we see here is what we're doing is we are just going to compare which one is larger. So if you all remember the alligator rule, basically what that says is the alligator is going to eat the bigger one. So here we see 8 larger than negative 6. It's going to eat the bigger one. But when we look at our next slide, a better definition I like is the alligator is going to eat the more positive one because it looks like 64 is bigger, right, than 15. But hold on, we have the negatives there. So negative 15 is actually going to be more positive than negative 64. So the alligator is going to clamp down and eat the more positive one, in this case, negative 15. More practice on comparing integers. Here, just ordering integers on a number line. So what we do is we just go ahead and put a dot where it needs to go. So we get positive 5 here. So therefore, we go to positive 5, and here it's already there. We're just going to emphasize the dot. Negative 2, find negative 2 on the number line. Just to emphasize the dot right there. Perfect. So remember, on this number line, further right is positive, and then further left is going to be more negative. So I just like to label the number line just to give me some sense of orientation. Here, order from least to greatest. What we can see here is positive 5, if it's the least, there's no way positive 5 is the least, so that one's not right, because we got negative 5 after that. That's going down, not going from least to greatest, so we can go ahead and cross out that answer. Let's see, negative 5, negative 4, negative 2, 1, and then 5. So that looks good. That looks like exactly what we have up here. So that looks good, but let's just go ahead and wait just a moment. Let's compare the last answer. Positive 5, positive 1, negative 5, negative 4, negative 2. So again, it's descending. It's not increasing, so we can cross that out. So it looks like our answer here is B. All right, more practice. Again, we can do less than, greater than, or equal to. We see here positive 10 is greater than negative 6. I'll just do a couple. 5 is greater than negative 1. And then we get 9 is greater than negative 6. Oh, kind of a pattern there, just by chance. But okay, keep going. Opposites and absolute value. What we see here is that opposites, they're numbers that are the same distance from 0 on a number line, but in the opposite directions. So it makes sense. They're called opposites, right? So positive 10, negative 10. So they're the same distance, right? So they're, let's see. I'm just going to try and draw a brace there. So that's 10 units. Here, that's 10 units. So we can see here, they're the same distance from 0, 10 units away. They're just going in different directions. So therefore, 10 and negative 10 are opposites. All right, so the number of units, or the distance between an integer and 0, is called the absolute value. So when we think about a distance, so if we think about New York to LA, that's about roughly 3,000 miles. So whether you're going from LA to New York or New York to LA, it's 3,000 miles. It's not going to be negative. It's a distance. It's always going to be positive. When we think absolute value, when we think absolute value, it's a distance. It's always positive. All right. So again, since we think absolute value, we're thinking a distance of an integer from 0, so it's always a distance, so it's never going to be negative. It's always going to be positive. That's just some further review down there. What we see here is we use, this represents the absolute value. So here, this is asking us to take the absolute value of a number. Pardon me, let me go back to my pointer. So if we see negative 15, what's the absolute value? Positive 15. Negative 2.5, the absolute value, 2.5. Here, 2 minus 5, so just treat it like it's in parentheses. So 2 minus 5 is going to be negative 3. So when we throw that through there, remember, absolute value is never going to be negative, so it's going to be positive 3. 12, it's already positive, it's going to be 12. And then if we scroll down, we got a couple more. Again, just do the operation inside first. 3 plus 7 is 10. Throw it through, it's 10. Again, it's staying 10. Negative 2 minus 9, that's going to get us negative 11, but since it's absolute value, it's got to be positive. Throw it through, it's 11. All right. That's not working, so we're going to move on. Here, just further test. So again, what I like to do is just go ahead and take it one at a time. So absolute value of 15 is 15. Remember, absolute value is going to make whatever is in there positive after doing whatever operation is within. So we got 15 plus 19, so that should give us 34. Let's see if we're right. Beautiful, 34. All right, let's go here. 14 plus 7 is 21. That's already positive. Absolute value makes it positive. So it should just be the same thing. 21 it is. All right, this last one is unique. All right, so negative 16, the absolute value of that, again, it's going to take that negative 16, make it positive. So we got 16, and we got all minus. Careful, we're not distributing here. We're doing what's inside here first. So 8 plus 3 is 11. So we're going to do 16 minus 11. That should give us a value of positive 5. Let's go ahead and check that. Beautiful, we get a value of positive 5. There's more there for you to practice if you'd like. All right, here just dragging and dropping where these fall. So negative 1, is it smaller than negative 5? No. Bigger than 0? No. It's between negative 5 and 0. Let's go 7. That's definitely bigger than 0. And then negative 7, that's definitely smaller than negative 5. All right, graph these numbers on a number line. Again, I just see, oh, okay, I like to orientate myself. Negative is over here. Positive is over here. I find negative 7 right there. I'm going to go ahead and put the dot on the number line. Negative 2, I go ahead and plot negative 2 on the number line. 3, find 3, plot it on the number line. I'm just putting a dot right exactly above it. So not a little bit to the right, not a little bit to the left, but right exactly where these two lines intersect. And then 6, I'm going to go ahead and put a dot right there as well. All right. Here are the answers to the practice set. We didn't get to that in class today, but it was just more practice of the concepts that we had discussed. And then again, our objective for today was to graph points on a number line, compare and order integers, recognize sets of numbers, and to find the absolute value of a number. And then the homework was the starred problems in lesson 1. So don't miss those starred problems. Do every single problem in the written practice of lesson 1 that has a star, and then do all of these also. So that is the homework due Wednesday at 8 a.m. I'm available at tutorial from 10:45 a.m. to 11:25 a.m. and then let me know if you have any questions. Thank you so much, and I look forward to seeing you all in class soon. Have a good day.